Oh, and by the way, you can cache these files just like you can cache just about anything. A couple different ways you can cache it. We'll go into VDB caching a little bit, but this is the simplest way. Remember, everything that comes out of this PyroSim, out of the output, gets split up and sent out to the Pyro imports. These Pyro imports here are where the final outputs come out. So you click on here, and actually we just sort of hide these two. You'll see both of them disappear. You see the original flame source as a kind of VDB volumetric object there. It's swirling and undulating, doing its thing, but that's not really what is the final result. In fact, you may want to turn those off when you render, because this is really the output of the smoke, these Pyro imports. So if I go to the Pyro import smoke, you'll notice we have the same sort of situation we had before, where this .io is the thing that's rendered, and this sort of .import visualization node is what's seen in the viewport. So if I click on this and turn this off, I click on, let's just make a new cube. Oops, not cube. Well, curve, that's fine. If I make that visible, and these two, this is invisible, it'll render this here always, because it's a render override. But this is what you're actually going to see, this whatever object there. Just made that sort of an empty object. But that's the thing that's seen. If you control click on this guy, you'll actually make that renderable, and that's the sort of override there. So this is rendered, this is viewport. Same thing with here, the Pyro import flame. You have this visualization node, which pulls from the Pyro node, which has visualization sort of presets. These presets here under visualization, we have the multi-visualization, multi-field turned on, and it's using these presets for the smoke and emission. Okay, it's pulling from that information and diving it into the flame node, and that's what's being visualized. The Pyro field here is producing all of these fields: density, velocity, rest, temperature, heat, fuel, all this information here. And we can export this out. We can actually save this out and load this onto a disk. This is not just a render node, but also the way we can save out the cache. So a lot of cool things in there available to us. In fact, we can save all of these fields. We can save the density field, which, as we said before, was how thick that volume is, how dense it is, how opaque it is, I guess. Velocity field. Now here's a cool thing. We haven't actually looked at this before, but if you click on the PyroSim over here, you dive inside of there and go to the Pyro source fuel. Here it is. It's the flame one. And we go to the visualization here, visualization. We turn on the velocity field. We actually have this cool way of visualizing what direction these things are going. This is a matrix, a vector field, and every node of this volume has a partition, has a velocity, and this will show you which direction it's going and how fast. Usually higher velocities are from the center, and it slows down as it reaches the outside of the field. And you can control that too. If you go up to the velocity field, you can turn on, use smoke if you wanted to, and actually see it as smoke volume, which is cool. Each one of those, it's like a normal map. Every color also shows the direction that it's going to. It's like a normal map field. Turn that back off again, because this is a little bit easier to see. You can change the plane position as far as its position in space, and kind of gives you an idea. It kind of cuts the plane along a certain axis, and you can tell which axis, X, Y plane in this case, which is the X value here, left and right, and the Y value up and down. You can make this, of course, the YZ plane and go that direction if you wanted to, and change the plane position along that direction, or the ZX plane, and show the vertical partition. So again, you can visualize all these fields, which, especially with velocity, is really super important. You may want to go through and sort of see what your velocities are doing, and even add what's called advection. You can push the velocities. You can push these around with different advection fields, but we'll get into that much later. So there's a visualization type speed. We can also go distance too, which will kind of show you the distance it's going. It's direction, which is more of a normalized value with no speed involved, but the speed is kind of the direction and a speed and a velocity. And you can change the visualization scale, the colorization there, and the range 0 to 1. can obviously go higher, over crank it, or under crank it if you wanted to, but most of those values are there for your methods of breaking down and analyzing the positions. You can turn on heat, of course. There's the heat field. The burn, where the gas is being burned out, and it's burning from the center pretty evenly. Divergence, fuel, where the fuel sources are. Temperature, again a temperature field, kind of like your usual infrared camera view of the temperature. And density, of course, is just a simple density field. If you turn the multi-field off, you can see just the density by itself. But the multi is kind of a density and temperature, and it does a lot of different things combined together. We have temperature and heat and density in the smoke, yada yada yada. Cool. So anyway, that all is being piped into each one of these visualization fields here. That's what you're sort of pulling from that. This geometry data path is visualization, so it's pulling from that visualization from the DOP object, the dynamic operator. This is what we're actually going to output out. So let's go ahead and just save this out as a geo. It's called a .geo, geo file, and several geo files, in fact. And I'm going to go ahead and save this to a file. So under geometry file, we have this saved actually as a it's untitled. So let's save it out. Before you do any saving of any caches, you need to save the file originally. So go to my Flashpoint examples, Houdini examples file. Cool. And we'll call this one volumetric cache. I should probably call it Fume Effects, not Fume Effects, but PyroEffects caching. Okay, cool. So that's the file name. Now, when I do this $hip, that means it's going to go to its origination. I know within that folder where I've just saved it, there is a folder called geo, and that's going to be called hipname underscore or $os, which is just the name of the file, pretty much. Just this sort of PyroEffectsCache. $os, I believe, is this import pyro field. Let me put this in here. I think that's the $os. $f is the frame number, and .bgeo, .sc. BGO is a binary geo file. Don't have to worry about anything like that. So now we can go ahead. We have it saved to a file location. We've got this geometry file location named here. We could, if we wanted to, just override that and just put in $hip. That's where we just saved our file. That's the location. Okay. Then we'll go into the geo node, $hip, and we have a geo folder. There it is. So $hip/geo, and we can call it whatever we like. We can call this one fire sim example $f.geo. It's going to put a BGO. It's going to call it BGO. We could say BGO if we wanted to. It's going to, whatever we call it here is going to override. It's going to use that file format. If we just name it, it's going to use it. $f is important. We need to save, let's say, 20 frames or 100 frames. It doesn't really matter how many frames we want to do, but under save file, we can go start here and here. I'm going to go ahead and delete that channel. So we're going to end it at frame 40. Just going to hard code that as frame 1 to 40. And when we're done, save the disk. So when we do this, if nothing bad happens, you're going to get this little file, little indication that's going to save those files out. And now I can go back to the top level, and I'm just going to make everything invisible, so we sort of pretend like we have a brand new scene here. There's nothing else in the scene. Just temporarily forget about those things. I'm going to type in geo node, type in geometry node, pop that in there, and then inside of there, we can actually access those files we just made. So under geometry file, I'm going to go here to the default geo. I'm going to go to the hip/geo. I'm going to grab the file I just made. So if we go to last modified and keep show sequences as one entry, it's going to go fire sim example $f BGO. If I turn this off, by the way, you'll see all the individual files. If I turn it on, it's going to grab all of them as one full sequence. Hit accept, and there's your file. It's all loaded in, smoke and everything. Beautiful. And I can go back to the material palette here, and I can take this flames material and I can drop that on there, and now it'll render using those flames, and I should get the same result as I did with the simulation. Yep, there we go. So we got the same exact results, but now I can play this back and forth, and there's no tie to any simulation. It's just cached out. It's just going frame by frame, loading in each individual sequence, and that's a great way of saving a lot of your flames. If you have a room full of fire, you can save 1 or 2 or 3 simulations, adjust the values a little bit, and then just pop them in with these little geonodes with these cached files. So that's that.
Ahoy, sir.